All right, so this video goes over lesson 5 in unit 4, solving systems of linear equations algebraically using the substitution strategy. Okay, so first we start with a warm-up, solving the linear system graphically, which is what we've done already. So to solve graphically, we need to graph both of these linear equations and see where they intersect. So for our first one, our m is 2, which we're going to write as 2 over 1, and our b is 3. So we're going to begin at 3 on the y-axis, and we're going to move up to right 1, down to left 1 to reverse it. Okay, I'm going to connect these, and we will have graphed the first linear equation. Y equals 2x plus 3. Okay, now I'm going to graph the second one. We'll do that in a different color. Here our m is negative 1 over 1, and our b is 9. So I'm going to begin at 9 on my y-axis, and my slope is negative 1 over 1. So I'm going to move down 1, right 1, down 1, right 1. Bingo, down 1, right 1, down 1, right 1. Remember, we are looking for the point of intersection, so we found that pretty early on here, all the way up here. Okay, so I'm going to label this line y equals negative x plus 9. And our point of intersection is the point 2, 7. So it is one solution, and our solution is 2, 7. All right. Essential question, how can we solve this linear system algebraically? So I'm going to go through the steps right now with you that are on the next page then. So algebraically would mean by solving for x, solving a multi-step equation. So I'm going to rewrite my two equations. We have y equals 2x plus 3, and we have y equals negative x plus 9. Okay, so to solve algebraically, what you're going to do is look at our equations here. So we know that y equals all this stuff here. Y equals 2x plus 3. So what I can do is take that 2x plus 3, and if it equals y, well, then I can plug it in right here for y, because 2x plus 3 equals y. So I can plug that in for y and rewrite my equation as instead of y equals negative x plus 9, it's 2x plus 3 equals negative x plus 9, because 2x plus 3 is the same thing as y. So I can substitute that in for y, and now I have a multi-step equation that I can solve for x. So to solve for x, we move all of our variables to one side. So I'm going to add x to both sides, right? This is like 1x. Then I'll be left with 3x plus 3 equals 9. Now I want to move all my, let's draw my line, move all my constants to the other side. And I'll be left with 3x equals 6. Divide both sides by 3. And I know that x equals 2. Okay, so that was the first step. Now the second step is I can take this value for x equals 2, go back to my originals. You're going to want to pick the original that you think is easier to work with. So I'm going to pick y equals 2x plus 3 because there's no negatives. And if I know x is 2, I'm going to take that and plug that in for x. And now I can solve for y. 2 times 2 is 4, 4 plus 3 is 7. So now I know y is 7. So what I did was I plugged in my value for x into one of the original equations. Okay, so this was step, let's see. So the first thing we did was we took 2x plus 3 and we substituted that in for y, and we solved for x. And then we plugged in what we got for x into this equation. So over here we solved for x. And then up here, let's see. We plugged in for y. So we plugged in for y. We solved for x. And then we plugged in our value that we got for x into the original to solve for y. Okay, then we have our solution. Our solution goes x comma y. So our solution here is 2 comma 7. All right, so let's look at these steps. If both of the equations are written in y equals mx plus b form, which they were, we substitute the expression from the first equation in for y in the second equation so that a linear equation is the only variable x is created. So when we did that and we plugged in, we then had all x's to work with. We plugged in for y in terms of x, so then we could solve for x. Basically, we set the two equations equal to each other and then to get rid of the y. So everything was in terms of x. We solved for x. Then we substituted our answer for x. We got x equals 2. We took that 2. We put it into one of the originals to solve for y. And then you can check by substituting the solution into each equation. So I'll show you that moving forward. Okay, so now let's solve this one. So let's start by solving graphically like we have done in the past, where our m is 2 and our b is also 2 here. So I'm going to start at 2, and then I'm going to move up 2, right 1, and down 2, left 1. That was y equals 2x plus 2. And then for the other equation, there's an invisible 1 there as a coefficient. So our m is 1, or 1 over 1, and our b is negative 1. So I'm going to begin at negative 1, and then I'll go up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1, down 1, left 1. There's our intersection point. All right, circle that intersection point as soon as you hit it. Again, this is solving them graphically, which we did last week. Y equals x minus 1. All right, so we already know our solution right here is negative 3, negative 4. That's our point of intersection. But now we're going to get the same solution, hopefully, by solving algebraically. So to solve algebraically, I'm going to rewrite my two equations. And we're going to take one and plug it in for the other one. So I'm going to take this 2x plus 2 and substitute it in for y. And I'll rewrite my equation as 2x plus 2 equals x minus 1, not equals 1. Now we can solve for x. This is 1x, so I'm going to minus 1x on both sides. And then I'll have x plus 2 equals negative 1, right? Because 2x minus 1x is just 1x, so x. I'm going to minus 2 on both sides. And then I will get x equals negative 3. Now that I have x is negative 3, I can go back to my originals. I'm going to pick y equals x minus 1 for this one because I think it's going to be one less step because there's nothing to multiply by. And I'm going to take this x equals negative 3 and plug that in for x. So if x is negative 3, let's put that in, and now we can figure out what y is. Y is going to end up being negative 4 because negative 3 minus 1 is negative 4. Now I know my x, now I know my y, so my solution is negative 3, comma, negative 4, which is exactly what we got when we solved by graphing. Two different ways to find the solution to a system, graphing and by using substitution. Okay, let's do another one. Solve the linear system graphically and algebraically. So let's start by solving graphically. our slope is -3. I'm going to write that as a fraction. And our b is 5. Start at 5 on the y-intercept, go down 3, right 1. Up 3, left 1. And again, I'm going fast with the graphing of these because this is old at this point. So go back to the past videos if you need help graphing them. And label. Okay, my next one, I'm going to move up 2, right 1. My slope is 2, so 2 over 1. And my y-intercept is -10. Oh boy, so that's all the way down here. Up 2, right 1, up 2, right 1, up 2, right 1. There's our intersection point. Up 2, right 1. And label y equals 2x minus 10. And our intersection point, it looks like it's 3, -4. Okay, now let's solve algebraically. So I'm going to rewrite our equations. And we're going to take the expression over here for 1, that's equals y. So I'm going to take that and plug it in for y because it equals y. So I can take this -3x plus 5, put that in the place of y, and now my whole equation is in terms of x, so I can solve for x. I'm going to solve for x by minusing 2x on both sides. Get all my x's here on the left. Move all my constants to the right. Divide both sides by -5. And I'll end up with x equals 3. Now I can take that 3 and plug it into one of my originals. I'm going to pick the original that doesn't have the negative. I think it'll be easier. So I'm going to take this x equals 3 and plug it in for x. Now I can solve for y. 2 times -3 is -6. -6 minus 10 is -16. Y is -16. What did I do wrong? Oh, it's not -3. X is 3, not -3. See, I knew it was wrong because we solved it already and we got -4, not -16. So let's just fix that. So x is 3, not -3. So 2 times 3 is +6. And 6 minus 10 is -4. Okay, so our solution is 3, -4. For this one, I'm just going to show you how you could check it. So for the check, you could take this point, 3, -4, and plug it into both equations. So we have y equals -3x plus 5, and then we have y equals 2x minus 10. So let's plug in -4 for y and 3 for x, -4 for y, 3 for x, and see if it balances. -3 times 3 is -9, and -9 plus 5 is going to be -4. So that point fits on that equation. This one, -4 equals 2 times 3 is 6. 6 minus 10 is -4. So the point is also on that equation. So again, to check it, you take your solution, plug it in with x and y values to both equations and make sure it fits. That means that that point is on both of those lines. And if it's on both of those lines, it's where both lines are crossing or intersecting. Okay, we're just going to do one more together. Again, let's start by solving graphically as review. Okay, so the first one, our slope is 3. Or 3 over 1 we can write it as, and our b is -7. So I'm going to begin at -7 and then go up 3, right 1. Okay, and then my other one, let's see, I'll do this in blue. Our slope is 3. 3 over 1, I'll rewrite it, and our b is 1. Begin at 1 and go up 3, right 1, up 3, right 1, down 3, left 1, down 3, left 1. Something's going on with these two. These have no solution. We graphed some parallel lines. They're never going to intersect. All right, so let's look at what would happen if we solved these two algebraically. So again, it was y equals 3x minus 7 and y equals 3x plus 1. So we're going to take the one term, the one expression 3x minus 7, and plug it in for y since it equals y. And I'm going to rewrite these then. So we have 3x minus 7 equals 3x plus 1. Okay, let's solve for x. Minus 3x on both sides. The x's cancel out on both sides, and we're left with this. Negative 7 equals 1. We learned this before, right? Negative 7 doesn't equal 1. So it's no solution. Whenever you get two numbers in the end that don't equal each other, it's no solution. So again, you could solve it graphically by graphing them and seeing that it's no solution. Also, same slope, different y-intercepts, going to be no solution. And if you solved it algebraically using substitution by plugging in the one expression in for the value of y and trying to solve for x, you would get that the two numbers don't equal each other, so that means no solution. And keep in mind, for infinite number of solutions, it would be like 3 equals 3 at the end. So that might come up also maybe in the next lesson. All right. Bye.